Hi. So our topic is variation of parameters. So in this session, we will solve one example. So this is our differential equation: y double prime minus 4 double y prime plus 4y equals x plus 1 times e to the power 2x. Okay, so that is a linear differential equation with constant coefficients, right? So we are going to use the method of variation of parameters to solve this differential equation. So in the first step, let me change my marker color. Okay. The first, we need to solve the homogeneous, associated homogeneous equation, right? Here, let me just write here y double prime minus 4y prime plus 4y is equal to 0. So the auxiliary equation for this would be m squared minus 4m plus 4 is equal to 0, or m minus 2 squared is equal to 0. That is m sub 1 equals m sub 2 is equal to 0. Repeated roots, right? So then y sub 1 will be e to the power 2x, right? Y sub 2 will be x times e to the power 2x. So we can get the complementary solution of this differential equation. This will be c sub 1 times e to the power 2x plus c sub 2 times e to the power, here we have x, 2x. Okay? So the second part, now we need to find the particle solution of this differential equation. On the right hand side, we have x plus 1 times e to the power 2x, right? Actually, we're using that previous method that we have learned in our previous videos. We can solve this, but here we are going to use this method, variation of parameters, right? Usually this is a general method, right? We can just solve this for any type of function which is here. So first we have to determine our f. It's already in standard form. The coefficient of y double prime is 1. So for this, our f is this. So we are looking for particle solution of this differential equation, and we are hoping that it is in this form: u1 of x times y sub 1 plus u sub 2 of x times y sub 2, right? And for this, our f function is, what is it? X plus 1 times e to the power 2x. Okay. So now the first step, we are going to find our Wronskian determinants, which is y sub 1, y sub 1, y sub 2, and here we have y sub 1 prime, y sub 2 prime, right? Which is equal to y sub 1, it is e to the power 2x, and y sub 2, x times e to the power 2x. And if you differentiate this, we get here 2 times e to the power 2x. And if you differentiate this one, first differentiate this e to the power 2x plus x times 2 times e to the power 2x. So here we have 2x plus 1 times e to the power 2x. It's just 2 by 2, and if you evaluate this, and we get here e to the power 2x times 2x plus 1 e to the power 2x minus 2 times e to the power 2x, right? And this times this minus this times this. So here we have x times e to the power 2x. And which is equal to, if you just evaluate this, we will get e to the power 4x, e to the power 4x, right? And 2x minus 2x is equal to 0, only 1. So that's equal to e to the power 4x. Okay. So now we need to find capital W sub 1, right? And the first column of this determinant should be replaced by 0 and f. What is f? That is x plus 1 times e to the power 2x. The second column is this, x times e to the power 2x, and here we have 2x plus 1 times e to the power 2x, which is equal to 0 times this equal to 0 minus this times this, right? So that is x plus 1 times e to the power 4x. In a similar way, we can evaluate w sub 2. That is, the first column is this, that is e to the power 2x. So here we have 2 times e to the power 2x. The second column, here we have 0 and f of x. And f of x is x plus 1 times e to the power 2x. So if you evaluate this is equal to 0, so here we have x plus 1, right, times e to the power 4x. Okay, so now we can get u sub 1 prime, which is equal to w sub 1 over w, which is equal to w sub 1 is minus x plus 1 e to the power 4x. And how about w? W is equal to e to the power 4x, which is equal to minus x squared minus x. And how about u sub 2 prime? That is equal to w sub 2 over w, which is equal to w sub 2 is equal to this, x plus 1 e to the power 4x over e to the power 4x. So that is equal to x plus 1. Okay. So now we are going to just integrate both sides, and we will get u sub 1, and integrate both sides, we will get u sub 2, right? And so from here, u sub 1 is equal to integral, and what we have here is equal to minus x squared minus x, that is our u1 prime, right? And here we have dx, which is equal to minus 1 over 3 x cubed minus 1 over 2x. And we don't have to write this constant. All right. And a similar way, how about u sub 2? That's equal to integral, right? That is, here we have x plus 1 dx, which is equal to 1 over 2 x squared plus x. So now we got u sub 1 and u sub 2, right? And we just erase this. I don't need it. Okay. So our particular solution that would be here, y particular is u sub 1 y sub 1 plus u sub 2 y sub 2. And what is our u sub 1? U sub 1 is from here, u sub 1 is e to the power 2x. And u sub y sub 2 is x times e to the power 2x. So here we know this u y1, and u sub 1 is here minus 1 over 3 x cubed minus 1 over 2x. All right, we don't this is fine. All right, here we have cube, here we have squared, we have squared, and y sub 1, that is e to the power 2x, plus, here we have u sub 2, that's equal to 1 over 2x squared plus x times, and y sub 2, that is x times e to the power 2x, right? So we get particle solution. So now we can write the general solution of the given differential equation. Dots, dots, dots. So the general solution of the given differential equation, then the complementary solution plus particular solution. And what is complementary solution? That is c sub 1 times e to the power 2x plus c sub 2 times x times e to the power 2x. Plus, now I need to write this particular solution. We just write here plus minus 1 over 3 x cubed minus 1 over 2 x squared, and here we have e to the power 2x plus 1 over 2 x squared plus x. Here we have x e to the power 2x. And now we can simplify this part, right? E to the power 2x, e to the power 2x, right? If we just take this out, here we have cube and squared, here we have squared, here we have x. So in a more compact form, we can just write it as c sub 1 e to the power 2x plus c sub 2 x e to the power 2x. And here, if you just simplify this, we have 1 over 6 x cubed, and the e to the power 2x plus 1 over 2 x squared, and here we have e to the power 2x. Right, because if you just remove the brackets, here we have 1 over 2 x squared times x is x cubed, and minus 1 over 3 x cubed plus 1 over 2 x cubed, that's equal to 1 over 6 x cubed. And here we have x squared, half x squared, right? Negative half x squared, and here we have x times x squared, and their sum equals half x squared. And that's just the same thing. So this one is the complementary solution of the given differential equation, and this one is the particular solution of the given differential equation.